probably. Okay, you got logarithms, got more than one logarithm. So if you had to isolate logarithms, then you're going to have to do something to get them together. How are we going to put logarithms together? Well, in the end, once we've put these together, we're going to use one-to-one property to solve it at the end. But how do I put these together? Remember the homework from last night? You do what? You apply which property for these two? A product property, right? You're going to condense like we did last night in the homework. Right? These two are a product property. You know, you can write that as ln of x minus 2 times 2x minus 3. Right? What property can I use on the right-hand side? The exponent, the power property, right? So how would I rewrite that? Ln of x squared. Okay. Now it's one-to-one, right? If ln of this equals the ln of that, then this equals that. Right? It must be that x minus 2 times 2x minus 3 equals x squared. So now we're left with an equation to solve. In this case, it looks like it'll be a quadratic. So how do we solve? Well, we better simplify the left first. FOIL it, right? If we FOIL these two, I'm going to get 2x squared. I'm going to get minus 3x minus 4x, which is minus 7x. And then negative 2 times negative 3 is plus 6. Okay. Then what? No. No. Subtract the x squared. Remember, most of the quadratics, when you solve them, you want to get everything on one side, 0 on the other. And from there, you can do anything. Quadratic formula, factor, graph, all these things. So if I subtract the x squared, I get x squared minus 7x plus 6 equals 0. And that is a fairly basic factoring problem, right? Right, the two numbers is product of 6 and sum is negative 7. X minus 1 times x minus 6. So what are the answers? X equals 1 and x equals 6. Okay, here's the part where you got to check, because you can't take the logarithm of a negative number. It's important that we check both of these answers and make sure that they don't lead to the logarithm of a negative. So on the next slide, I'm going to do that. Right? I'm going to plug in x equals 6 and then x equals 1 and just make sure that they check. Right? For x equals 6, I get ln of 6 minus 2 plus ln of 2 times 6 minus 3 equals 2 times ln of 6, which is ln of 4 plus ln of 9 equals ln of 6 squared. Right? These I can condense. That's the ln of 4 times 9, right? And on this side, it's the ln of 36. So obviously that's true. It checks. Right? Now, see what happens if I plug in the 1. ln of 1 minus 2 plus ln of 2 times 1 minus 3 equals 2 times the ln of 1. Right? Now, the ln of 1 minus 2 is the ln of negative 1. You can't take the log of a negative number, right? I mean, the second one was the same thing. It was the ln of negative 1. The right-hand side is 0 because the log of 1 is 0. But in any case, because of these two, it's extraneous. So that's an extraneous solution.
So we're going to have to check every time.
for logarithms. For logarithms, you need to check. You know, especially if you got that kind of thing going, you know, it's plus or minus, then it could actually lead to a log of a negative, right? Can't take the log of negative.